All right, there we go. I think we're up. Let's make this public.
For you, sir, always.
We have company.
Understood, sir.
Awesome. All right, we're live. So, yeah, welcome everybody. If you're watching the recording of this after, at the moment, it's pretty much just me, but we'll see. We'll see if people join. That's not really the main purpose of this. If people want to join, that's fine. If they don't, that's fine as well. But today, I'm going to be streaming my participation in the virtual participation, not real participation, of Code Forces round 669. So this was a Div 2 round. I couldn't do it because I had other things going on this morning, so I wasn't able to compete live. And just before we start, I want to get this out of the way. I'm not doing this live. Don't do contests live. Don't stream participation in contests that are going on at the moment because it allows people to cheat if they watch you. So in general, that's a really bad thing to do. Don't do that. However, this is not that. This is a virtual participation, and this should be fun. So yeah, it's also a good way to practice, I think. Do we want to do 2010? That might be a bit much. Let's do, I'd say 7, so we have a couple minutes. So yeah, we'll start the contest in 2 minutes here, and we'll see. Welcome people who are joining now. Today we're going to be doing round 669. I'll have my eye on the chat as well most of the time. Hello, PK Champ Gaming. Good morning. How's it going? Hello, Banu. Hello, Panadeep. How's it going? Did you guys do the contest today? Good morning. Yeah, good morning indeed. So yeah, I'm gonna be competing pretty soon, and then we'll see. I'll try and do all of my thinking. Do my thinking here, so that way you guys can see it. Good morning, Sudiravan. Sorry about the names. I'm very bad at names. That's just kind of one of my weaknesses. We do have company. I actually shut it off earlier. But yeah. All right, let's go. Good luck, have fun. What a problem name. Holy cow. All right. Alexandra has an even length array consisting of zeros and ones. The elements of the array are enumerated from 1 to n. She wants to remove at most n over 2 elements. Is n even? N is even, okay. At most half the elements, in a way that the alternating sum of the array will be equal to 0. Got it. So first thing minus the second thing plus the next minus the next. Okay. She wants the sum of elements at all odd positions and even positions to be equal. Got it. The elements you don't remove don't have to be consecutive. Okay. Print the number of elements that will remain after removing in the order they appear in A. Then print k numbers. Should print the numbers themselves, not their indices. I see. Okay, so if we have half of them are ones, we could print all ones. half are 0, we can print all zeros. And since it's only zeros or ones, then we can always do one of those. Good morning, PK Champ. Thank you for waiting for my screencast. Sorry I couldn't give it to you earlier today. Let's do that screencast now. A bunch of zeros or a bunch of ones. Let's see. Okay, this has half of them zeros, that has half of them zeros. This has half of them ones, that has half zeros. Looks good. Let's submit. Move on to problem B, and we'll listen for our result. Big Vova. Alexandra.
Wrong answer, test one, sir.
Oh, hang on. Whoa. Oh, because I see. Because if n is 6. Wait, wrong answer, test 1? This is test 1. Okay, for a bunch. So first, this is the number of elements that will remain. And then, yeah, okay. So this solution's just not even right, too. So, like, yeah. Because this doesn't work. That's not legal. I'm saying it is legal, but it's not. So first I need to print how many I remove. Okay, so if it's, yeah. So if n mod 2, or n over 2, mod 2, if this is odd, equals 1, this out 1. Else this out. Okay, so now, to remove, what the heck, over 2. Okay, and then here we need n over 2 floored. K is the number you remove, right? Wait, what? Remain. Okay, so it should be plus then. One remains, you have a 0. One remains, you have a 0. 2 remains, you have 2 1s. This remains, you have 2 zeros. Okay, let's do the break case though. So this would be 6, and then four ones. Yeah, that works. Okay. Got A wrong on a div 2. Oh my goodness. It's kind of funny. All right. Second thread is back. I am back. Yeah, they predicted my misfortunes with the problem names. We got it though. So yeah, Tanver, that could have an answer, but n equals 4 array 0 0 1 1 1. You could just print 1 1 as well, so you can do better. Let's move on to B. We spent too much time on problem A for problem A on a div 2. It was like almost 6 minutes. Okay, Alexander is a well-known programmer. Today he finally decided to go out and play football but with the first hit, he left a dent in the new Rolls Royce of Big Vova. Okay, you're given n positive integers. Using each of them exactly once, you're to make a sequence of some integers that, wait, what? Okay, you're given array A. You want to make array B that array C is lexicographically maximal, where C is the GCD of the first I elements of B. So you rearrange the elements in A into elements of B. He's really afraid of the condition of this simple task, so he asks you to prove it. A is lexicographically smaller than B. Yeah, okay, we know that. Of conditions. Got it. Yeah, all right. So the first number has to be the biggest of them. Then you want the biggest factor of that, then the biggest factor of that, etc. All of the things are small, so that's easy. So yeah, you just take the biggest element, then the biggest factor, etc. Okay, so array list is probably helpful. That way we can remove. And then first we want the biggest thing. Okay, so I guess, yeah, let's just get the max. Okay, so now n times we want to get the biggest factor of this if it exists. Otherwise it doesn't matter, right? Yeah, so okay. So int max, well, yeah, int max factor equals -1 for int I in the list. I want to do this forever. And then once we're done, we want to print whatever's left. If there are multiple solutions, print any, I hope. I'm really afraid of reading the chat though, because I'm worried someone will just like post the answer and then I'll see it and like, yeah. But at the same time, I want to read chat, but we'll see. I'll try and like hold off on it while I'm solving problems, maybe. Yeah, okay. What if there are multiple answers? Yeah, multiple answers print any. Okay. So then sys out this thing plus a space. Okay. So we want to print the biggest factor. So if I or max mod I equals 0, max equals I, max factor equals math.max is max factor and I. These are all positive. Sounds good. Okay, now list.remove max factor. Okay, so if this is -1 break, otherwise remove it. And then print it. Max factor plus a space. Then print everything else in the list. And then, oh, this isn't true. We don't want the max factor, we want the max GCD. Yeah. Okay, so max GCD width equals first I get 0. This needs to be the GCD. Okay, so now the max GCD equals this. If this is greater than the GCD of I in the GCD, then max GCD width is I. If I equal, so this is max GCD width now. Remove this, print this, and then GCD equals the GCD of GCD and max GCD width. Okay. Index out of bounds exception. Index to. Oh. Is how you do it? I think that's how you do it. 2, 5, and then we have index out of bounds 0. Okay. Not list dot is empty. 2, 5. What? All right. My GCD right. If b equals 0, return A. Yeah, that seems fine. Should be 5, 2 for sure, right? Yeah. It's 2. What the heck? Oh. Five, 2, 8, 2, 1, 3. Yeah, okay, that's fine. Okay, so bounds are tiny, so this is easy, I think. Yeah, we should be good. All right, now let's read problem B, or let's read the chat on problem B. Yeah, not much, but straightforward brute force. Yeah, yeah.
Well done, sir. AC on problem B.
I searched multiple in my browser, Anand, by just doing Control F. Yeah. Please solve interactive problem C. Okay, well, I'm on it then. Let's do interactive problem C. Someone says it's interactive. Maybe it's interactive. Chocolate Bunny. Oh, man. What a name. Chocolate Bunny. We hid a permutation P of length. I'm so excited to solve this problem, guys. I can't tell you. I'm so excited. We hid a permutation P of length n consisting of the elements 1 through n. You want to guess it. To do that, give us two different indices, I and j. We will reply with this first thing modulo the second thing. We have enough patience to answer at most 2 times n queries. Huh. Interesting, interesting. So, I'm gonna stop reading the chat until I have at least mentally solved, because I don't want to spoil it for myself. So, my first idea is let's find the 1, because if we can find the 1, then we can just get everything in order n queries. So the question is, can we find the 1 very quickly? If some integer, yeah, we'll keep track of like the smallest thing, I guess. So we'll query everything with the last thing, and if that isn't equal to, or if it is equal to 0, that means the first thing's divisible by the second thing. So here's what this looks like. So we've got some array of things. We'll query this first thing with the last thing, and if that's 0, that means this is smaller than this. So that means like A is smaller than B. So we'll keep track of this like minimal thing as we go through the array. And eventually we'll hit 1, which will be the smallest thing in the array. So yeah, so we'll query this, and then we'll keep track of the smallest. It'll be one of those two. Then we'll query this. We'll get whichever one is smaller, but it's not necessarily whichever one's smaller, right? It's just some of them. Then we'll keep doing that. Eventually we'll find the 1 after 1 passed through the array, so that'll take like either n or n minus 1 checks, I'm not sure. But then after that, oh, no, hang on. What are we trying to do? We're given the mod, so the 1 doesn't help us at all. Yeah, the 1 is totally unhelpful. The n is helpful though, if we know what n is in the array. Okay, so let's try and find n then. So, okay, so because if we can find n, then we can say anything mod n will be what it is. So how do we find n? Well, if we have this value mod this thing, what does that tell us? Say, so there's a 6 somewhere in here. We have a 6. 3 mod 6. This is a 3. Yeah, so if we do 2 of these, we can identify one of these. We can say this is a 3 for sure. So in the first 2 queries, is n at least 2? Oh man, it's at least 1. Well, if it's 1, we can special case it. If it's at least 2, then we can identify the first 2 things by doing these 2 queries. We can do A mod B and B mod A. Does that tell us anything? It tells us which one's bigger. Yeah, so we can get the bigger of A and B. Let's say this one's bigger for simplicity. Now we'll calculate this. We'll calculate this thing mod this. Yeah, okay. So if we know, oh, then we need to figure out what our value is, though. All right, maybe instead we do like a segment tree sort of thing. Segment trees have 2n comparisons total. It might cause issues if n is in a power of 2, though. So that's 2 of them. If we have this, then it's... I guess that might be fine. Yeah, so what if we do a segment tree thing? So if we have 1, 2, 3, 4, 5, 6, we can identify what the smaller of these is in 2 comparisons. We compare both of them. Now we know which one's smaller. So we have that smaller thing. We can remove it. We do the same thing for these 2. Oh wait, no, this is easy. This is easy. If we can compare 2 to get 1, then we just, okay, so now we know whichever one's smaller, we know it's that one. Now we have the bigger one in this one, we just do 2 comparisons here. Like that and like this. And then we can figure out what one of them is. We keep going. So that'll be 2 times n minus 1 comparisons. Yeah, okay. Cool, so that's the idea. So just to summarize, because that train of thought may have been difficult, if you have 2 numbers, like let's say you have a 3 and a 6 or something, or 3 and a 7 maybe. If you do 3 modulo 7, that'll be 3. If you do 7 modulo 3, that'll be less than 3. So whichever one of these is bigger, this is bigger, that means this 3 is equal to 3. So we can place it and move on. That's my solution idea. That'll take exactly 2 times n minus 1, which is what we're looking for. Cool. Yeah, okay. So 10 to the 4. Then you're allowed to make 2 inquiries in the following way. Okay. Single test case, I hope? Yeah. Alright, so we have n. So now we have some stuff. Okay, well, this is kind of annoying that they made it like this, but that's fine, I guess. Boolean array alive, or I guess used a Boolean array n. 4 int I equals 0, or 1, I is less than n, I plus plus. Int previous index will be 0. Okay, and then we'll have figured out everything. Array ants is new int array n. We'll have figured out everything except for this previous index. So now 4 int I equals 0, I is less than use.length, I plus plus. If not used at I, then ants at the previous index will be equal to I. We print like an exclamation point before our answer? Yeah, okay. So the exclamation point, then a space, and then a new line. Alright, so now for each of these things, we want to print ants at I plus 1 plus a space. Okay, so now we just have to do this part. So yeah, okay. So now sys out a question mark followed by the previous index plus 1 plus a space plus I plus 1. Okay. Int mod value is this next thing. Alright, then do the same thing but backwards. Int mod value 2 will be this. So if mod value is less than mod value 2, then mod value 2 is the real one. Is it the first mod the second or the second mod the first? They give you the first mod the second. So if mod 2 is the real one, this, and the second one is smaller. So ants at I equals mod value 2 minus 1. Used it, ants at I equals false. And then prev index will stay the same. Otherwise, prev index will equal I. Used at ants at prev index will be false, and then ants at prev index will be equal to mod value 1, because that one was bigger. Okay. I think this is fine. Let's try it. There are 3 elements. Let's say it is 3, or let's say it's 1, 3, 2. So value 1, mod value 2, that's 1. Value 2, mod value 1 is 0. Value 2, mod 3. So 3 mod 2 was 1. And index 3 mod index 2 is 2. 132, that's right. Okay. Let's read chat. Anton's here, welcome. I wonder if that's the real thing. I suppose you are the real thing. Hi, Anton. The reason I suppose so... Oh, there we go, we got it. Is because I don't know... Like, I don't know if people who would copy you. But yeah, I'm a huge fan, too. You're a cool guy, Anton. Alright, we got C. Very good. Good morning, everybody. Good morning, Kirshan. Java isn't bad. Java's alright. Java, yeah, it's not the end of the world. I have tried C++, Emiliano. The reason I use Java is because my ICPC teammates use Java. And I want to use the same language as them. Is Java a good choice for code forces? Probably not. C++ is probably a better choice, to be honest. If your goal is doing well in code forces, and especially if you first start out learning, then C++ might be the way to go. Alright, he's got more solves, so let's read it. Actually, let's see who's solved it. Then we'll read it. K-Sun solved D and then E. Okay, good job to him. And it looks like no one else who's taking it seriously really has. So we'll read both, I guess. Or I guess let's just read D first. Discrete centrifugal jumps. They're n... How do you read weird long input in Java? Because I'm really struggling to do that. What do you mean by weird long input? I just read a long, right? So if you want to... Like, if you mean read like a lot of integers, like an array, then you can use this class. So like take a screenshot of this, and then you can do that, or it's just in my submissions. If you want to read a long, then you read this next, and then you do long.parseLong right here. It's just a big integer. Okay, let's read from D. And beautiful skyscrapers in New York. The height of the ith one is this. Today there are some villains who have set fire to the first n-1 of them. Oh man. This sounds like somebody read the news before writing this problem. And now the only safety is the nth skyscraper. Let's call a jump from the ith skyscraper to the jth one discrete if all skyscrapers between are strictly lower or higher than both of them. Yeah, okay. So, yeah, if all of the ones between, so if you're jumping to the right, if all of the ones between are either higher or lower than you, then that's discrete. Okay. He's staying at the first skyscraper and wants to live a little longer, so he wants to reach the nth skyscraper with minimal discrete jumps. Help him calculating this number. Well, sure, it's always possible. Thank you for doing this and not saying it's guaranteed the answer exists. I appreciate it. The minimal number of discrete jumps, huh? Well, I wouldn't say it's obvious. So I would imagine initially it's some sort of DP with like a segment tree range min query or something. But that's tricky because the things you can jump to are... It's like not obvious what those are. I guess let's draw a picture, huh? That's the good thing to do when you're stuck. So you've got a bunch of skyscrapers. Wait, they need to be all higher or all lower. Okay, interesting. So, yeah, so if you have something like this, you're in trouble. So then, so you can't ever, so you've got like some, oh, that's kind of cool. You've got like some, in this case, what can you jump to? Let's make it, let's not do this. Well, in that case you can't do anything, but if it were like this, then you've got some like stack of monotonic things you can hit. So here, that's fine. Okay, so now it's down, which means everything else has to be, okay, everything's lower. Oh, I guess this also works. So this is a monotonically decreasing chain. You can hit any of these things. but that's it. If we have anything higher, that's unreachable. Because you can't go from here to here, because that would be worse than this. Okay, so you also have the same thing flipped upside down. I guess the next question is like, how does this change, I guess, when you add a new element? So if you have something like this, if you've got some chain, oh man, this is weird though. So like, what does it look like in this case if you're here? You can reach this. You can reach this. Okay, the next one goes up, which means you want some like decreasing. So here we can only hit, this is it. Okay, maybe that's a bad example. Yeah, so we want some decreasing chain. Okay. We want a decreasing chain where everything but the... do we want to go as far as possible? Is that beneficial? Maybe, but also maybe not. It's hard to tell. If you've got like a bunch of lines, you want to be really low. It's good to be really low. Because if like you're really far down, then you can skip to like the last, well, maybe it's good to be low. It's hard, it's not obvious to me. Maybe it is, maybe it's not. Oh, I guess it's the things you can see, huh? It's the things you can see if you look one way and look the other way. If you look left, what towers can we see? We can see this one, and this one. Are the towers all different heights? No, okay. Or not. Is this important? I guess it's important. For people just joining, I see we've had a bunch of people join recently. I'm not reading chat during problems because I don't want people to spoil the problems for me. So I don't want to like, yeah, I don't want to like read the solutions basically. Especially because I'm sure most of you guys have already seen these problems because you've done the contest. I'd imagine at least. So you can watch me be stupid, but I don't want to just like read the editorial in chat. That's kind of why I'm avoiding chat at the moment. So we can jump to some if we look at the things we can see. Can you ever jump to something you can't see? Not if you're jumping above everything. Yeah, so you can only jump to these things that you can see. Because this, yeah, it's either below or not, okay. So you look at this sequence of like new, or like, yeah, these like maximums. So this is a monotonic chain. So we have this, there's some prefix that's beneficial. So we can binary search what that is. Then we want like a minimum along that or something. Yeah. Oh, but we can just naively do this, I think, as well. Since, okay, so let's look at it like this. If it's small, if it's smaller than this, if it's smaller than or equal to this, so if it's in this range here, then in the future, we won't be able to use this thing at all. So we're gonna, or that's if it's bigger. If it's smaller, yeah, if it's smaller, whatever, we can only use it. But if it's bigger, if it's like in here somewhere, then this is gonna get popped off the stack anyway. So we can just walk naively. We don't need a segment tree or anything. Yeah, okay. So I think that's it. We just have to be really, really, really careful to not get anything wrong and not handle the equality incorrectly. So the idea is when we're at some, we've got like some monotonic chain going up. We'll also have some monotonic chain of decreases. So it's new minima. Yeah. So initially it would have been just this, then it gets replaced by this, then by this. Then we would have had this and then this. And they both get replaced by this, then it gets replaced by this. Okay. So yeah, so the idea is for each half, like keep popping from the stack as long as it's helpful. And then along that, take the best DP value. Because you can hit any of the things that you might pop off the stack. And then you put yourself on the stack. That's the idea. We can implement that, I think. It's not too bad. It's easy to mess up, I think, but not too bad. Let's make sure we've read the problem right. The biggest here is less than the minimum here. The max of the two heights. Wait a minute. Yeah, the biggest in the range is less than the minimum of the heights. Yeah, okay. Or the max of the two heights is less than the min in the range. Yeah, that's right. Okay. Cool. So maybe we should have a class to handle this. Static class stack. Yeah, okay. All right, so we'll read A and then the array, or N and then the array. And N equals this, int array A equals read array of size N. Okay. Int array dp equals new int array size N. dp at N equals 0. Okay, so we're gonna need some stuff here. So we're gonna need, well, let's just do the methods first. We'll need public void push, some index, and then some DP value. Okay. And then we'll also need, I guess we'll just do index and then height. I guess this will just be prep. And this will return an int. Okay, and then public void push int index and height. So now we'll need an array deck. And then also the DP values. This is value rather. So in this case, indices dot push back, or yeah, we also need the heights. So add first the index, and same thing for the values, and then same thing for the heights. Okay, so that pushes it. Public void pop. So while not in indices is empty, and not values dot is empty, and not heights dot is empty. Well, these will all be the same. Okay. Okay. So while this is true, and yeah. Okay. So we also need the greater thing. So this will be assuming heights are positive. And then we'll just have two of these, one for them being positive, one for them being negative. So while this is true, and heights dot peak first, while this is less than or equal to? Well, it's less than me. Yeah, less than height. Then I can read from it. So int ans equals integer dot max value, return ans. Okay, so then ans equals match dot min of the answer, and the values dot peak first, and then pop this from the array because we will replace it. Okay, so I think that's fine. Do we care about this DP even? I don't know that we do. We might not. Yeah, I don't think we do. So stack array, or stack positive and a negative. So positive will be a new stack, and negative is also a new stack. And then positive dot add, or positive dot push index, and the why am I storing the indices? Because we don't actually use the indices for anything. Yeah, I guess it doesn't matter. Maybe debugging will be helpful. Value will be 0. The height will be a at n-1. And then also negative dot push a at negative n-1. Okay. So now I guess we'll just write the DP here. So then our answer will be, or do we start at dp 0? Yeah, okay. So sys out dp at 0. So that's the answer. And then we need to process all these positions. The index will be I, the value will be heights, will be A at I, and then negative dot prep, the index will be I, value negative A at I. Yeah, okay. Value is the answer. Oh, this plus 1. And then the height will be 8i. Same thing with negative. And then print dp at 0. Huh. Print 4. So we can go there, I think, is the important part. Let's look at this. That's 2. Am I always 1 too big? We shouldn't start at n minus 1, we should start at n minus 2. Wait a minute, what? That should have fixed it. Okay. So 3 things, 1, 2, 1. Or I guess let's just do 2, 1, 2. It's easier to think about. Three things. Two. It shouldn't take 2. It should take 1. dp at 1 is 1. dp at 2 should also be 1. Why is that? Okay. So let's say when we have -2 and then 1, we pop height -2. Then when we have this 2 again, negative. The answer shouldn't be 2 still. It should be 1. Popping height -2. So, yeah, that's right. Okay. And we should pop height 1. Okay, is this wrong? I think this is wrong, because we can still peek from the last one. Yeah, okay. So let's make sure we've got this right here. So if we have this, and then we have this thing here, then we remove, like if here are towers, then in the future we won't be able to see this or this. Let's say we can see this one as well, maybe. But then you can still reach this one. So yeah, so we need to continue looking here. So if not indices dot is empty, answer equals math dot min of the answer and values dot peak first. Okay, that's finally right. This is 3 indeed. That is 1, should be 1. That's also 1. That is 2. Looks good. Those samples, I guess, despite giving several samples that are quite long, that the samples aren't very good, I think. But that's fine. Runtime, let's double check runtime. Should be linear. I think it's linear. So I'm not too worried. Let's submit. Oh, Colin's here. Welcome, Colin. All right. Oh no, someone told me line 23. Uh-oh. Are people debugging my code for me? What's with line 23?
Wrong answer, test 13, sir.
Wrong answer, test 13. All right. Well, I'm gonna read the chat anyway. Hopefully people don't tell me what's wrong. All right. Man, lots of people. Okay. Hi everybody. My C took almost a second. Is that something to do with Java? It might be something to do with Java. I'm printing every second, so that might be why my C was so slow. I think I read the question incorrectly. I guess I'll go look at that. Ivan, if you're looking for my template, you can go to any one of my Codeforces submissions, and you can like just take from those submissions, right? So just look at my submissions. At the very bottom is the fast scanner. Yeah. Also, like here you guys go. Lots of people are asking for it. You can just like take a screenshot right now, and that's it. That's my input. Next reads a string that's space separated. Next int reads an int. This reads an array of length n, and this reads a long. The things in between have to be all greater or all smaller than both the heights. Yeah, I think that's how I understand it. Most subs are from India. Yeah, that might be. I think most people, most of my subs are from India. The fast scanner methods I kind of just talked about, right? Okay, lots of stuff. Buffered reader is slow for interactives. It is, yeah. Probably should have been using scanner for interactives. But buffered reader is faster for most things. So, okay. So let's see. Why are we wrong here? Wrong answer, test 13, huh? Is this in... Well, I guess maybe we should make a good test case for ourselves. What would a good one be? What if we have something like 5, 4, 3, 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 4, 3, 2, 1. How many things is that going to be? This is 5, 6, 7, 8, 9 times 2, so it's 18. And then this is doable in 3 steps, so you can get to the 5 in 1 step, 2nd step, 3rd step. So the answer here should be 3. Darn, I get it right. Okay. If worse comes to worse, I can write a brute forcer for this, because it's pretty easy to write data for. Data is just a random array, and then the n cubed is easy. So I'm not too concerned. This should be right though, right? Answer starts here. Well, the first thing is less than the height. Then you can hit that if you want to. Then remove this index. Maybe this 3, 2, 1, 2, 3, 1, 2, 3, 2, 1, 3, 2, 1, 2, 3, 1, 2, 3, 2, 1. I think this is just 20 then. So this should take 1, 2 steps, then a third step. Oh, I suppose. Yeah, I suppose this is actually cheesable. Because there are other ways of getting 3 here. We could go 5 to 5 to 5, or no, that's not good. Yeah, okay. So this is 1 step to the 3, 1 step here. So 1, 2, 3, 4, 5, 6, 7. So 7 steps, I think. They can do it in 6. Okay, 1 step to the 3, 1 step here. Oh, because you could go to, yeah, you could just skip this part. You could go like that. 1, 2, 3, 4, 5. Wait, how do you do 6? 1 to the 1, so that's 2, 3, 4, 5, 6. Yeah, okay, that's it. 3 to the 1, then skip by 1s. I think that's true. Yeah, I'm not looking for help, Colin. Thank you, though. I appreciate the offer. Let's just generate some stuff then. Let's do brute force first. Brute force should be quite easy. I guess multi-test case is good. And then int n equals this. Int array a equals this. Okay, so now for int j equals I plus 1, j is less than n, j plus plus. For int k equals I plus 1, k is less than j, k plus plus. Boolean have higher. Oh, wait a minute. Oh, yeah. This isn't necessarily true at all. My solution's just wrong. Because if you have... Wait, what if we have this? What does that mean? No, that's fine. Yeah, that's fine. I think we're good. Okay. Have higher equals false. Have lower equals false. If have higher and have lower, then continue. So if it's between, then it's impossible. Is there anything between the two? Yeah, okay. So if a at k is a at I is less than a at k, less than or equal to, and a at k is less than or equal to a at j, then continue outer. Otherwise, I guess maybe 1, 2, 3 would be a good test case. Let's try that first. Yeah, okay. So if a at k is less than a at I, then have lower equals true. Otherwise, have higher equals true. Good. Okay, so now we've handled both of these, otherwise it's possible. Now dp fill the array with a billion. And then dp at I equals math.min, dp at I, dp at j plus 1. And then dp at 0 or at n minus 1 equals 0. Just like that. So let's make sure this passes all the data. Looks good. All right, so then we just need to generate stuff. Then we need random. Oh, we have that already. Int n equals 1 plus random dot next int 5 maybe, or let's do 6, I guess. Well, 5 would be awesome. 4 would be even better. Let's try 5 though. Okay, lots of data. Looks good. Then we just need this to be multi-test case. And then let's try this with the brute forcer as well. All right. Oh, they're different. Okay. So line, I can't touch the screen. Line 37, I think, is the first difference. Yeah, I say the answer is 1, and the answer is actually 2. Okay, test case 37. We'll start on line 2 times 37 plus 1. Yeah, no, pad plus plus hype, Colin, right? That's what you code in usually, I think. So line, yeah, test case 37. So we just, oh, 37 times 2. Nobody make fun of the fact that I don't know what 37 times 2 is. 74, thank you. 311, that's so easy. What? What? Let's work this out. So what I'm saying is that if we have this thing here, what does it look like? 113. Yeah, okay, I'm saying we pop both of these, but I can't reach the second one. That's obnoxious. Do we just have to pop it here? Is that the only difference? I think so. If height step peak first is equal to height, then pop. Or is my solution idea just totally wrong? So, yeah, okay. This needs to be that. And then, good. All right, let's go. I get the first test case wrong now, I think. So I say it's 2. The answer is 2. Wait, what? Oh, you just copied the wrong thing. Yeah, it looks fine. Nope, don't submit the brute force. Submit this. Man, that took a long time. For a problem that wasn't really that bad. Assuming I even got it. Alright, alright. What's going on in the chat? Chat has calmed down. Will there be an episode of Algorithms thread about geometry? That's a good question, maybe. Runtime error test 1? What? Because there's single test case.
Problem debug runtime error test 1, sir.
Yeah, so, like, geometry in general is kind of hard to make an algorithms thread on, because geometry, yeah, okay, we got it. Geometry is, like, such a big topic. Like, it's kind of like DP, right? Like, you can't explain DP in, like, a reasonable time. Like, explaining all dynamic programming concepts would be just huge. For blue coders, I guess, so like the main things is you need to know some dynamic programming, like segment tree stuff. I guess maybe like disjoint set stuff, tree stuff, graph stuff. I'd say do like, if you do, yeah, I'd say if you do if you're trying to be blue, I would say if you do all of the educational stuff, the Codeforces EDU stuff, and then you do like the algorithms thread on segment trees and like RMQs and tree basics. That's probably enough to be able to be blue. Probably don't need much more than that. Anon says you tried doing the question with that Go recursive function, but you couldn't combine it with stacks. You got TLE. Yeah, so like if the Go recursive function is really good if you're just doing it normally, but like it's hard to do it efficiently. Seg tree is definitely not necessary for blue. Yeah, I don't know. I guess maybe usually for blue you don't code problems with it, but I think the concept is pretty important. Like the concept of turning something linear into log. Usually that uses like the segment tree sort of ideas. So you should be familiar with that, I think. Plus it's just like, you might not need to code it every time, but it's like a very basic data structure. And if there's one data structure you need, it's gonna be a segment tree. Like anything that you're gonna use to cheese something is probably gonna be a segment tree. Like you don't really need an RMQ data structure because you could use a segment tree. You don't really need a Fenwick tree. You could use a segment tree. Prefix sums are probably a good idea to know, but segment trees also work for those, usually. So yeah, prefix sums are also super important. You want to know those as well. Oh, you're already blue. Yeah, trying to get better. Yeah, then exactly. Pretty much exactly. So like, those are the things you should definitely do. Segment tree stuff, and then other mildly interesting topics. And then also, I think, like, for the most part, like, a good way to practice if you're trying to get good is to do contests like this. So either Div 2 or, like, if you're better than that, do Div 1 contests and stuff. And then whatever problems you don't solve, if you read the editorial and it ever mentions, like, it uses this concept or idea or something, and you're not familiar with what that is, then spend, like, a couple days and only learn that topic and do, like 3 or 4 or 5 practice topics on that topic until you're confident that you know how to do that thing. And then once you know that thing, go back and solve the problem. But like in that time, don't worry about solving other problems, just focus on that one isolated topic. And then once you have that down, you can go back and solve the problem, and then that's like a good way of learning something concretely. But basically the main use of these Code Forces problems isn't to just repeatedly solve problems over and over and over again, because that's helpful, but it's not that helpful. It's to introduce yourself to concepts that you wouldn't otherwise know. Should you learn bit if you already know segment trees? Binary index trees are helpful mainly because they're less code, and they're faster, like by a constant factor. So I guess maybe don't prioritize it. Don't prioritize binary index trees if you know segment trees, but they're good to kind of understand. There's a really good, not algorithms thread, Algorithms Live video on it by Matt Fontaine that I'd recommend watching if you want to learn binary index trees or Fenwick trees. It's Algorithms Live episode 0. It's like 45 minutes long. It's really good. Okay, anyway, let's see if we can finish this in 40 minutes. Igor in the Republic of Dagestan. Igor is a famous Russian singer, rapper, actor, and blogger, and he finally decided to give a concert in the sunny Republic of Dagestan. There are N cities in the Republic, some of them connected by M directed roads without any additional conditions. In other words, the road system is an arbitrary directed graph. It's good to say arbitrary because it's not acyclic or something. He'll arrive in City 1 and travel to City N by roads along some path, give a concert, and then fly away. As any famous artist, Igor has a lot of haters and 2 annoying fans, so he can only travel by safe roads. There are 2 types of roads, black and white. Black roads are safe at night only, and white roads in the morning. For the trip, his manager is going to make a schedule. For each city, he'll specify its color, black or white, and then if the trip... Wait, the roads are only safe at night or the cities? The roads, I guess. Okay, black roads at night, white roads during the day. He'll specify a color, black or white. Then if if during the trip they visit some city, the only time they can leave is determined by the city's color. Night if it's black, white if it's morning. After creating the schedule, he chooses an available path from 1 to N, and for security reasons, it has to be the shortest path. Igor's manager likes this person very much and wants to stay here as long as possible. So he asks you to make a schedule so that there will be no path from 1 to N, or the shortest path will be as long as possible. I don't know that I understand. So the roads have colors. Yeah, the roads have colors. The roads are either black or white. And then you want to color the pad. Wait, you want to color the cities black and white? Got it. Okay, so you pick either all of the black edges from a city or all of the white edges. The path's length would be as long as possible. So you've got two groups of edges you can pick, I see. What if you have a cycle? Well, let's draw what this is. So you have 4 nodes or 3 nodes. You've got 3 nodes. 1, 2, 3. The edge weights from 1 to 2 are 0. This is 0. From 1 to 3 are 1. From 2 to 3 are 0. And from 2 to 3 is 1. Yeah, okay, so it doesn't matter what you color 2, but you want this to be, you want to pick the 0 edge, and then you pick these.
Always a pleasure hearing you work, sir.
We have company?
Understood, sir.
Okay, so it's tricky. Yeah, it's tricky because there's cycles in this thing. So if we can ever, yeah, okay, there's no reason to take a cycle. So do we process some SCC all at once? We've got some group of nodes here. SCC by what definition, though? Because, like, these edges are sketchy. Okay, the first question might just be, can we even separate the whole thing? So we want to see, can we draw some line separating these two? Ever. Yeah, am I understanding this right? Let's do this other sample too. 4 nodes, 8 edges. 1 to 1? What? Is that possible? Alright. 1, 2, 3, 4. 1 to 1 with label 0. 1 to 3 with label 0. 1 to 1. I guess let's just color these red and blue, huh? One to 3 blue. 3 to 2 red. 3 to 4 blue. 2 to 4 0. 2 to 4 blue. 2 to 4 red as well. Okay, so yeah, that makes sense. Okay, so if you ever have 2 edges to the same thing, then you have to take it. You can have some weird cases, though. You can have cases where it's like something like this. So if you have this case here, you can split this up here. You can do this. This is like a particularly interesting case, I think. Maybe let's look at the last node that we hit the finish from. Whatever this last node is, it needs to have both edges going to the finish. If it didn't have both edges going to the finish, we would redirect the second edge to something else. So we can union these two into being like the same node. Now this 3 has both colors going to the finish, so the 3 can be like counted as part of the finish, I guess. So we count that as well. Now the 1 has both edges going to the finish, or has edges going to the finish from both colors. So we count that as well. So it's basically a BFS from the end, I think. Yeah, it's just a BFS then. So, okay, so how do you do it? So the idea is that BFS, so we start at node 4, or start at node n-1. We're trying to get to node n-1, right? That's the goal. Yeah, travel to city n. So start at node n. Then we want to see all nodes that can only reach reachable nodes. So yeah, so iterate through everything. I guess they can reach reachable things both ways. And then process all of those. So that's the solution idea. So let's code that up real quick. Very good, problem E. So static class node. Yeah, so we want a couple things, I guess. So we want array list node in red, and then also in blue. Then we want boolean red hit equals false, and then blue hit equals false initially. Public void, I guess, and then whether it's added as well. Okay, so then initially we just have n and m. N equals this, m equals this. So then we'll go through each node, or we have to make the nodes. Now we go through each edge. If the edge is, or we care about the 2 positions of the edge, right? So if A equals this, B equals this. So nodes at B dot in red dot add A, or nodes at A rather. Same thing for, oh, this is only, yeah, okay. So C is the color. So if C is 0, then do this, otherwise do the other thing. This one's red, otherwise make it blue. So nodes at n-1 dot red hit equals nodes at n-1 dot blue hit equals true. Array deck node BFS. Okay, so we also need the distance here. Thank you, Zero. Oh, man, what's going on? Thank you. All right. Sorry about that. So the distance will be initially -1 or something. Yeah, okay. All right, so now bfs.add the second last node for each node in the nodes, or well, I guess not bfs.isEmpty. Node next equals bfs.remove first. Okay, so now we need to consider each node that it comes from. So for node from in next dot in red, if from dot red hit, and continue. Otherwise, from dot red hit equals true. From dot dist equals next dot dist plus 1. And then if yeah, so if from dot blue hit, we don't need this added then, I don't think. Then bfs dot add from. Then do the same thing for the blue in degrees. So if blue hit continue, otherwise blue hit equals true, set the distance. If the red hit, then increment the red. Okay. If nodes at 0 dot red hit and nodes at 0 dot blue hit, then sys out nodes at 0 dot dist, otherwise sys out nodes at 0 dot, or I guess just print the dist anyway. Yeah. Okay. So now we have to print the answer though, right? So I haven't done the answer part yet, but we'll get there in just a minute.
For you, sir, always.
We have company 0.
Understood, sir.
I'm saying the distance is 1. Okay, what was the sample? 3 nodes. I drew it up here, right? Yeah, okay. So we've got a red. So it's like this, and then this. Oh, yeah, I'm just off by 1 here. So nodes at n-1 dot dist equals 0. verify all of these. Okay. So now we need to print the color of everything. Close. Okay. So now for each node, we just need to print its color. If they were both hit, it doesn't matter. I guess we'll just make this. So now for node nn and nodes, node.print nn.color, node.print line. Okay, so red is blue. So if red is hit last, then from.color equals 1, or equals 0, because red is hit last. Otherwise, from.color equals 1. Let's try it. 0, 1, 0, because you never leave node n, so that shouldn't matter, I don't think. 1, 1, 0, 0. Okay, that's fine. They're all 0. I think that's probably fine. Let's just submit it. And we'll check if it's not. Wrong answer, test 3. It wasn't fine. Okay, let's try it. Let's see what's going on. So we've got a graph with 5 nodes and 10 edges. 1, 2, 3, 4, 5. 1, 2 is red. 1, 3 is blue. 1, 4 is red again. 2, 3 is blue. That's probably important. Yeah, okay, well, we'll try that for a minute. 2, 3 is red. Wait, 0 is red, right? Yeah, okay, so this should be red, not blue. Then, oh, 2, 3 is both of them, okay. 2, 5 is blue. No, red. 3, 4 is red. 3, 4 is also blue. 4, 2 is blue. 4, 5 is red. So if we make these two both blue, 2 and 4 both blue, yeah, that's fine. All right. Wrong answer test case 27, are you serious?
Wrong answer test 27, sir.
27? What? Alright, hang on a minute, that's silly. Why? What if it's one node? Distance is 0, 0 edges. Is that right? Or distance is 0, color is 0. Yes, maybe. Okay. What if it's 2 with 2 edges? 1 to 1 is 0. 1 to 1 is 1. What the heck? Oh, I guess. Yeah, I want one node with 2 edges. Okay, let's walk through the code first and then figure out what's wrong if I don't see anything, maybe. So, read in all of the nodes, read in the color. If the color is 0, then it's a red edge. So add B to the list of things that hits node A. Or add A is like an in-degree node from node B. If the color is 1, add it, but for the blue edges. Okay, the last node initially is part of both groups, so mark that as true. Then we've got this BFS, which starts with just the last node initially. Okay, so, well, the BFS, what else does my node need? That's all my node needs. Okay, so, well, the BFS isn't empty. We remove the first thing. Oh, is this add or add last? It's equivalent to add last. I think that's fine, but yeah, I think that's fine because we remove the first, add the last, so I think that's a non-issue. If from.red hit, then this is irrelevant. Otherwise, red hit is true. Distance equals next dist plus 1. Is this always bigger? It should always be bigger because the BFS should go in order of smallest to biggest. Because I always add to the end of the queue. Yeah, okay. So otherwise, blue color equals 0. Does this even matter? It shouldn't matter. This line shouldn't matter, but it shouldn't cause any problems. Because yeah, when it hit blue, hit it, set it to 0 anyway. So we looked through all of these. We also looked through all of these, set them both to the opposite color. This is a blue edge, then you should come from a red. When is the next thread coming? What is the next thread? What do you mean by that, Shivam? What did I do to the first thread? All right, so the story behind the name second thread, I guess that's kind of what we're getting at here. So initially, like, my friends were making, I don't know, I was like making some account for something I didn't care about, like I don't know, like some social media thing or whatever, I don't know. And someone's like, what do you want your name to be? So I'm just like, I don't care, just make it like second thread. So it was second thread because it's like, okay, my main thread is whatever I'm actually focusing on, and this thing I'll just do in a second thread. And then afterwards I'm like, yeah, that's actually kind of a cool name. So I made my code forces handle that, and that's just kind of where it's come from. The first thread was whatever I was like actually focused on at the time, which I think was like running a robotics team, to be honest. So yeah, that's the story. That's where the name comes from. My second thread was like something I wasn't focused on. It was the unimportant thing, which since has become like how I spend most of my time. But anyway. Colin, don't tell me, but do you know what on earth I'm doing wrong here? How I get to test case 27 am still wrong? I can't see the data, right? Oh, I can. Wait. No, I can't. Okay, good. It is a pretty cool name. I like the name. I'm really a fan of the name second thread. I think it's pretty cool. It's also unique enough that like it's not just used everywhere. If I use something like David, like everyone, like I can't get something named David. It's used everywhere. But second thread. Although I tried to get their website. Look at this. I tried to get secondthread.com, and it's owned by this. Well, it's owned by a Shopify store that sells clothing. How boring is that? So yeah. Man, how much time do I have? I've got 13 minutes left, and I would like to solve this. What am I doing wrong? Should I just generate? It's kind of hard to generate stuff, right? Like, there isn't really a more naive. Yeah, what's the origin of Galen Collin? Galen Collin, you should tell us. Colin Galen. Where'd your name come from? Is that a secret acronym that stands for something? Oh no, I'm told. Well, thank you, Anton. I appreciate knowing. So I guess we'll use that now. So I know my output is 1, the real output is -1. I'm saying it's possible when it's not really. Am I adding my edges right? Yeah. Is my approach not right? So my approach is we've got some node here. We've got this other node. It's got both edges going to you. Then you should join it. Oh, I'm not detecting that it can be separated, I guess. It is Anton, the problem rejector. Yeah, the one who's famously rejects problems. But that also means we get cool story, Colin. That also means we get good sets of code forces problems. So that when I review the problems, I say, this is a cool problem, this is a cool problem, this is a cool problem, right? Instead of just I hate this problem, this one was actually cool. I wind up having positive opinions of everything instead. Let's marry. I might be a little soon for that, Anton. How am I not right? It's array list of nodes, What am I doing? Okay. For each in red node, if this one's red hit is equal to 0, continue. For each blue node. Did I like forget to change one of these things here? Man, I guess I'm just an idiot. How much time do I have? Got 9 minutes. I can figure this out in 9 minutes. This is an easy problem. Okay. 2, 1, 1, 2, 0. Ah, there's a break case. What is going on here? What the heck? What am I doing? Not even printing them. Okay, this is I plus 1. Subtract 1 here. Two, 1, 1, 2, color 0. Duh. Yeah. Otherwise print -1. I even wrote the if statement, dude. Cool. Thank you, Anton. Appreciate it, man. I think if I were focused enough, I may have figured it out anyway. But anyway, thank you. Didn't know he was accepting proposals. Anton? For David. What's the problem you dislike the most on Code Forces? I hope that's a question for Anton. Not for me. I don't like hating on people's problems. Welcome, person from Indonesia, Robbie. Yeah, Anton doesn't accept problems, he only rejects them. Okay, cool. So that's the problem set. There are 5 problems, right? It's not a 6 problem set? Yeah, okay. How did I do? Probably not great. I was pretty informal there. And I've got some other stuff that I want to do before I go to bed. 57th place. Nice job, Galen Collin. You smoked me, man. Good job. Yeah, Monaghan beat me too. Good job. I got beaten by a guy who uses Python. Solid. And Geothermal, hope he gave up. Because this is a little disappointing, man. You can do better. UCF kind of sucked as usual. Yeah. I was setting the distances. So my bug here was that I was setting the distances after either color instead of after only both colors. So if you were only visited once, I would set the color. But yeah. So, well, anyway, it was fun having you guys here watch me code. It's like kind of some extra pressure. Makes it a bit more fun. Then in case I do something really stupid, then you've got people. Yeah, Anton in the chat. Go Anton. Anton Ors. Anton's a cool guy. I like him. Sam's also a cool guy, Sam. I like you too. It feels like you're everywhere, man. Why does that sound like an offense? It's not an offense at all. Anton's a cool guy. Sam White in the chat, yeah, right? Okay, yeah, so I guess, in a minute, well, I guess we might as well do it now. Just, do the solutions to all the problems. Because I'm sure there'll be some people, why do I always open, yeah, okay. It's just a force of habit. I didn't used to know there was a middle click, or maybe I didn't have a mouse that had a middle click, so I would always right click and then left click. But I know, I middle click to close tabs too, right? So I do that, I just don't, I don't know, it's just how I do it. That's what I do. Is Anton an IGM? Wait, where's Anton? Hang on, he didn't even compete. See, he better be in the announcement. I can't see the announcement because my VP isn't over. There you go. Thank you for the round coordination. Yeah, look at this. IGM. Well, is this recent even? There you go. Speak of the devil. Round 666. Nice job, man. I'm not the real prodigy. You smoked me today, Colin. Good job, man. Good job. Although, how about I'll try harder on round 670? How about that? Then 670 we can go for real, Colin. 1v1 on a Div 2. Or maybe like sometime later. It's a little late for tonight, but sometime later we can do a 1v1 on duels or something. Anton didn't create the problem set. IE created the problem set. It's fake news. 2 to 10? Oh, you know what? We can check that out with lgmsniper.com. And let's see, Colin. So second thread, Galen Colin, and I forgot how to spell Anton's name. Let's see. And then we'll see who wins. Some OP ratio. Yeah, you can use this to. Does it count div 2s? I think it, or maybe doesn't. Maybe doesn't. Yeah. Well, we'll show the ratio anyway, though. So second thread versus. Oh, hang on. So I've beaten you 13 out of 19 times in some things. And where is Anton? I've beaten Anton 14 out of 29. So Anton and I are almost 50-50. Yeah, does this count div 2s? I guess, let's see. Yeah, it does not count div 2s. Only in global rounds and div 1s. And for all of them too. So going back to like 590s, Galen. Or Colin. So yeah, I don't know, not bad. It's almost 50-50. It's almost 50-50 for Anton too. I'll use the excuse that I used to suck. Like in 2017, I was pretty terrible. Wait, but somehow I beat you in 2017. Maybe you were terrible too. Or maybe I just popped off on Goodbye 2017. When did you beat me? Lift level 5 challenge, I remember that. Yeah, I don't know. You only started in 2017. Okay. Well, I think me too, but yeah, that's fair. That's fair. Well, anyway. Okay. Cool. Yeah, so I guess that's it for the actual entertaining. LGM means Legendary Grandmaster. That's it for the entertaining part of the stream. I'm gonna do solutions now, but everyone knows what they are. So, for the people who are watching this after, then you can, I guess, look at this part of the video for solutions. So we'll talk about those now. They'll be pretty easy though, because the set in general was pretty straightforward, I think. Cool. So this ahahaha problem was a little tricky. I got it wrong the first time, just because thankfully I like didn't even read the statement. But if I had read the statement correctly, I would have gotten like wrong answer test 2 or something. The idea is you want to remove some numbers so that the sum of the sum of the even indexes is equal to the sum of the odd indices. Basically, what that means is if you look at the zeros and the ones, if you have half or more of them are 0, then you just print all zeros. The only time this won't happen is if over half are 1s. So if over half of them are 1s, that means you can have half or half plus 1. One of these two numbers will be even, right? If you have a number and some number 1 above it, one of those two will be even. So whichever one of those is even, we can have an even number of 1s. So basically, the idea is we can either have half of the numbers which are 0, so we can just have a bunch of zeros. Obviously, the sum of the even positions and odd positions will be 0 in both cases. Or we can have a bunch of 1s, so that we have an even number of 1s, where this is just half or half plus 1. And I'll go over the code for that. So the code's pretty simple. This is just if you can print zeros, then I print half of them 0. Otherwise, I print half of them 1. This takes care of making sure I print an even number. All right.
It's a pleasure hearing you work, sir.
We have company.
Understood, sir.
So that's problem A. On to problem B. Big Vova. Ooh, that would be fun, Colin. If we did a 1v1, and then I use C++, you use Java, that'd be fun. Okay, so for problem B, you have some array, you want to reorder it so that the prefix GCDs are as maximal as possible. So there are probably a couple ways of doing this. What I did is, obviously, if you have some array, whatever the biggest number is, has to be first. If you have a 7, for instance, and then everything else is less than 7, then your first index has to be a 7 because the first prefix will just be a 7, and you want that to be as big as possible. That's kind of like the greedy principle. So yeah, so whatever that first number is like kind of forced. Then after that, you want to choose some other number so that the GCD of the first two is as big as possible. It doesn't really matter what that number is, you just pick it and then place it. And then you keep doing that basically greedily. You can use math to prove that that'll work, but basically, if you understand how GCD works, it takes the min of the exponent of each prime. So if there are multiple choices that you can have here, you'll just pick them in multiple steps. But it's going to decrease in some way. And then each prefix is like all of these things will always come before anything that comes after it. So that's the idea. That's like kind of the proof. Maybe there's a better way of solving it than that, but basically the idea is like you pick the biggest number and then pick whatever number would make the GCD biggest and then remove that from the array. So it's just n squared, naively, but that works because bounds are small enough. Okay, very cool. On to problem C, chocolate bunny. The idea behind this one is if we have two numbers, whichever one is smaller, using two operations, we can identify that one and choose what its value is. So basically, let's say we have this. If we have the numbers, like if we have x and y, then we can check two things. We can check what is x mod y and what is y mod x. So let's say x mod y is equal to 3 and y mod x is equal to 7. What that means is we know y equals 7. And then we also know x is greater than 7. That's what these two things will tell us. We know this because whichever one of these is smaller will wind up just being recovered in the output. So the bigger output will correspond to the smaller of the two things, and that will just be whatever that thing is, whichever one comes first. So if we have some series of numbers, oh, I'm sorry, I didn't show the code for B. Here's the code. Yeah, it's pretty much just exactly what I said. For this one, if you have this series of numbers, you can compare the first two elements, and you can figure out whichever one's smaller, you can identify it and place it. So we can like get this one for sure. Now we have these next two elements, so we'll compare these using two comparisons. Whichever one's smaller, we can identify in place. Maybe it's that one. Now we have these two, we'll look at them, and then we place whichever one's smaller. Now we look at these two, we place this one. Finally, at the end, we'll be left with just one number, but we can very quickly identify what that number is, just by keeping track of whichever number is left over. So that's how we can get this one here. Okay, two more problems. Problem D is kind of interesting. So for problem D, you have a bunch of skyscrapers, and you can jump between two only if everything within the range is either smaller than everything or bigger than, or smaller than those two or bigger than those two. The idea is we're going to keep like a stack of towers. So let's say our towers look something like this, maybe. We'll keep a stack going down of like the next smallest tower as we get there. Or I guess the next like biggest tower. So you imagine if you go right, when would we hit the next biggest tower? In this case, we would get something that looks like this. Here's our stack. So yeah, it's like basically if you start here and go right, when do you hit the new maximum? Now we want to introduce this tower here and maintain this stack. So what we'll do is like iteratively pop off the stack until we have the next thing which is taller than what we are now. That's the idea. We can also build off of anything that's in this stack. So we can jump from these two. We can also jump from these two because anything within them is smaller. We can jump from these two because anything within is smaller. But then we're finished, so we just stop here. And that's kind of the idea behind the problem. So we keep popping from the stack as long as it's smaller. And this will handle the case where you look at all of the things that are below you. Now, each of these times we consider making this jump, which means we consider looking at this position in the DP, where our DP would store for each position how many steps does it take to finish. So at the end, it takes 0. For this thing, we would calculate the DP value here. That would be how many steps does it take to finish. So in this case, it would be 1. In this case, it would also be 1. And then in this case, I don't know, it'd probably be 2. In this case, it would be 1. In this case, probably 2 again, and stuff like that. So we would look at all of these positions that we would consider jumping to. We would check what they are, and then we look at what their DP value is, and we consider that value plus 1 as the value for this position here. That's the idea behind solving it. And this only handles jumping above a series of buildings. It's also possible to jump below a series of buildings, but to do that, we can imagine inverting all of the heights. So we can do this once with all of the heights positive, and then once again with all of the heights negative. The idea behind that looks like this. I keep this stack of positive and negative elements, and initially the stack contains just the last element. The second number here is the DP value of getting to that, so it's 0 here. And then I go through all of the other elements, and then I consider, like, I pop the things off before them, and then I add the DP value onto the stack. For the negative stack, I add the negative version of that number. Finally, the answer is the DP from position 0, because it's how many jumps do you need from position 0. Yeah, the stack logic is pretty much like I said earlier, so this prep will remove the things before you, and then it also considers jumping to the next thing. So yeah, that's the idea. We keep popping from the top, or we keep popping from the stack as long as these things are below us. Then if it's not empty, we might be able to jump to the next one. So we consider doing that, because there are a bunch of things below us, we can jump over all of them and hit the next one. But if the next thing is equal to us, then we can't jump to this next thing in the future. So that's why we have to skip this. And then this just pushes and pops from the stack. Okay, very cool. And then the last problem is problem E. So in problem E, you've got this directed graph, which may or may not be acyclic. It doesn't really matter whether it's cyclic. And what you want to do is you have edges in this graph that are of 2 different colors. You want to color each node so that each node will have only the edges that match that node's color. So the node is either red or blue. The edges coming out of each node are either red or blue. If you color a node red, all of the blue edges from that node get deleted. So the idea behind doing it is we'll consider doing it from the end first. So if we have several, I guess this was a good sample, right? So you have a blue edge here, a blue edge here, blue edge here, and then a red edge, and red edge. So at the very end, the last node that gets visited will be just this one here. One step before that, you'll be at this node, which will visit, like it won't have a choice, it'll have to go to the last node. The reason for that is both the red and the blue edge coming out of this node will hit this last node. No matter whether you color that node red or blue, it will be able to reach the finish. So that means this node has to have like some value to the finish. We can determine what that is now, and we'll just do that easily. For once we color this node in, we see this node here has both a red out degree that goes to some node that has to visit the finish, and a blue like outgoing edge that has to reach the finish. So we color this node here as like part of the finish. So the circle of dots that I've made is like nodes that are like considered part of the finish. Then we do the same thing for this node here. So now it has both of its out degrees go to some node that's in the finishing section, so we include it as part of the finishing section. We can keep doing this, and once we reach a point where there are no other nodes that have to go to the finish, that means we can separate the graph into two chunks. So let's look at the example here, the last example in this case. And this happens pretty quickly, actually. So in this case, you have a 5 just by itself. And we'll look at all of the incoming edges to the 5. They're all red. So we know this 2 here, we can't color it red. So it's either blue or nothing if we want to cut it off from the 5. So we can color it blue, that'll cut it off from the 5. We can also color the 2 blue, that'll cut it off from the 5. And if we do that, then we can stop our BFS because the 5 can't reach any other nodes from both a red and a blue path. So that's the idea. So basically, like the TLDR is we're going to do a DFS from node n-1, and we only consider another node like reachable if it's reachable both from red edges and blue edges. So yeah, that's the idea. Yeah, so to actually implement this, I store for each node all of the nodes that go to it with a red edge and nodes that go to it with a blue edge. And also whether this node can reach the finish if it's colored red, and whether it will reach the finish if it's colored blue. Obviously it doesn't want to reach the finish. So if both of these values aren't true, we'll just color it whatever the other color is that makes it not able to reach the finish. And then the distance is just like the distance to reach the finish, which I print at the end. So then to do this BFS, initially I start with just the last node in the queue. And then as long as the queue isn't empty, I'll pop a node from the queue. Then I have these 2 loops. These look through the red edges. The blue edges is just the same, but reversed, so I'll just talk about this. Basically, if there was some other finishing node that you can take a red edge from what we're considering and get to that node, then this node that we're considering, it's not significant, so we'll just skip it, right? It's basically just an edge we've seen before. It's not important. And the distance is just distance plus 1. This will get updated every time we see a new edge. So when we see the second color edge, it'll be set to that. So now if the second node, if this is the other color, so this is like if this is a red edge, if it was already colored blue, that means this is the second time we're coloring it. This node's now able to hit a blue edge. It was also able to hit a red edge. Since it's now able to hit both, that means this node has to visit the finish. No matter what we color this node, there's some path from this node to the finish. So we'll add it to our BFS. If not, we want to color the node whatever the opposite color is. So we just do that. This is the BFS. If the BFS ends early without having visited node 0, that means we can color the nodes in some way and separate the graph into 2 parts. So that's what we do. Otherwise, if we do hit node 0, then we print the distance to node 0, and then just print what we colored the nodes anyway. So yeah, that's the
Pleasure hearing you work, sir.
that's the idea behind the problems. The round obviously wasn't rated for me because I VP'd it, and I guess this was a little bit different of a format.
26,660 seconds.
What on earth? Alright, sorry about that. Yeah, so this was a much more informal, I guess, contest. It was a combination of practice and the fact that I wanted to have an editorial for the contest on my channel. But yeah, I guess that's all. So that's all from me. Hope you enjoyed the contest. Hope if it was rated for you and you're using this to look at solutions now, hope you enjoyed it. And yeah, thanks. Have a great day. And goodbye.